Lesson 5-4, adding and subtracting like fractions, and in this lesson you learn to add and subtract fractions with like denominators. Why is it important? Adding and subtracting fractions with like denominators will help you determine the fraction of each dollar of the allowance that you spend. Okay, let's take a look at this activity. As you learned in chapter 4, a fraction can be represented using a model like the one at the right. Different colors of shading can be used to show addition of fractions. This model represents 1/6 plus 2 over 6. Okay, this represents 1/6 right here. Okay, and this represents 2 over 6. Since 3 of the 6 sections are shaded, the sum of 3/6 or the sum is 3/6 or 1/2. So if you're adding 1/6 plus 2 over 6, 2 shaded out of 6, 1 shaded out of 6, add them up, you end up with 3 over 6 or 1/2. Okay. Now let's take a look at this activity. Okay. Draw and shade a model that represents the sum of 1/8 and 5/8. So if I want to represent 1/8, let's say I do green for 1/8. This will be 1/8 right here. Okay. And let's say I want to add it to 5/8. Okay. And 1, 2, 4, 5. Okay, 1, 2, 3, 4, 5. Oops, too much. Erase that thing right there. Okay, so if I add 1/8 plus 5/8, I simply count everything that's been shaded. 1, 2, 3, 4, 5, 6. It's going to be 6 out of 8. Okay, so how many sections of your model are shaded? And how does this compare to the sum of the numerator? So answering that question, 6 are shaded and they are the same. Okay. How many sections are there in your rectangle? Okay. So to answer that question, there are, okay, obviously 8. How does this compare to the denominator of the addends? Okay. They are also the same. Remember what addends are. Those are the numbers that you add to get a sum. Okay. And letter C, what fraction represents the shaded sections of your rectangle? We answered that already. That would be 6 over 8. Okay. And then if we come up with a rule for finding the sum of fractions of the same denominator, we simply say that the numerator is the sum of the numerators, and the denominator is the same as the denominators of the addends. Okay, so what does this tell us? It simply tells us this concept right here, that when you're adding fractions with like denominators, okay, they can be described by the following rule, and this is the rule. To add fractions with like denominators, simply add the numerators and write the sum over the same denominator. So if you put that in symbols for fractions a over c plus b over c, where c is not equal to 0, again this restriction is here because we cannot divide a number by 0 or else the number will be undefined. Okay, so we're putting that restriction, so everything will be defined in terms of our numbers. Okay, going back here, a over c plus b over c is the same as a plus a over c plus b over c, or a plus b all over c. So you're adding your numerators, keeping the denominator the same. Okay, so when the sum of the two fractions is greater than 1, the sum is usually written as a mixed number in simplest form. Okay, definition of a mixed number indicates that the sum of a whole number and a fraction. Okay, so when the sum of the two fractions is greater than 1, you can write it as a mixed number, which is also the same as the sum of a whole number and a fraction. Okay, let's take a look at what that means. Okay, in the next slide, in your book, in the next page, on the next page, solve each equation. You have 3/4 plus 3/4. Okay, going back to estimate, 3/4 rounds to 1 okay, and simply add 1 plus 1, you end up with 2. Let's put up the shade so there'll be suspense a little bit for this one. Okay, so estimate that to become 2. And now, according to our rule, we simply add the numerators 3 plus 3 and keep the denominator the same. You end up with 6 over 4. We want to simplify that further, okay, writing it as a mixed number. That would be 1 and 2/4. Okay, renaming 1 and 2/4 as a mixed number. Okay, remember how we do that. In order to make that into a mixed number, we simply divide, okay, 6 by 4, okay, and that is 1, 4, and you have a remainder of 2, okay. So this is your whole number right there. Your remainder is your numerator, and your denominator is your, and your divisor is your denominator, okay. Just a little bit of review how to find mixed numbers. Okay, let's go down here. So if you simplify 2 and 2/4, that would be equal to 1/2. Okay, so let's take a look at letter B. Y equals 3 and 2/5. Okay, 3 and 2/5 plus 4 and 3/5. Again, using estimation and the rules for estimating, 3 and 2/5 rounds to 3, 4 and 3/5 rounds to 5. So our estimate should be close to the number 8. Okay, and if you use the associative property of addition, okay, since they are all addition, you can do 3 plus 4 plus 2/5 plus 3/5. Okay, using addition and the commutative properties to add the whole numbers and the fractions separately. So we can add it right away. The 3 plus 4 is equal to 7. Okay, and 2/5 plus 3/5 is equal to 5 over 5. Okay, so 7 plus 5 over 5, or 1, is equal to 8. So the rule for subtracting fractions with like denominators is similar to the rule of addition. To subtract fractions with like denominators, subtract the numerators and write the difference over the same denominator. Okay, so for fractions a over c and b over c, where c is not equal to 0, again that restriction so that it'll keep the fractions from becoming undefined. A over c minus b over c is equal to a minus b all over c. Let's take a look at example number 2 and see how this works. Y equals 7 over 15 minus 28 over 15. Write the solution in simplest form. So in this case, we copy the problem, and since the denominators are the same, we simply subtract the numerators. So we now have 7 minus 28, and we know that 7 minus 28 is negative 21. Keep the denominator the same, which is negative 21 over 15. Put it into a mixed number, which is negative 1 over 6 over 15, or negative 1 and 2/5. Okay, so we rename as a mixed number, and then we simplify. Actually, you can simplify first, okay, and then put it into a mixed number. Because if you notice, negative 21 over 15, if you simplify, this is the same as negative 7 over 5. And if you put negative 7, if you convert negative 7 over 5 into a mixed number, that is the same as negative 1 and 2/5. So you can simplify that improper fraction and then put it as a mixed number. I find that easier than converting it into a mixed number and then simplifying it. Okay, so let's take a look at this one. Connection to algebra. Evaluate m plus n if m is equal to 3 and 1/6 and n is equal to negative 1 and 5 over 6. Okay, so this is an algebraic expression, and we want to get the sum, And remember, when you talk about evaluate, evaluate means find the value of, and two ways to find the value of: you need to substitute and you need to simplify. So copy the problem m plus n, and then we replace the values of m and n to be 3 and 1/6 and negative 5, negative 1 and 5 over 6. Okay, and then we take out the parentheses and we simply subtract 3 and 1/6 minus 1 and 5/6. Okay, and then we rename 3 and 1/6 to become 2 and 7/6 so that we can subtract 1 and 5/6 from it. You end up with using the associative property and the commutative property of addition, 2 minus 1 plus 7 over 6 minus 5 over 6, or simply 1 and 1/3 in simplest form. Okay, if you are getting confused from this step to this step, this is actually what happens. Let's take a look at a little bit of a review. 3 and 1/6, and you're subtracting 1 and 5/6. Okay, and since they have they have the same denominator, you can go ahead and subtract. But in this case, okay, when you're doing subtraction in this form, you cannot subtract 1 from 5 in this case. So what do you need to do? We borrow 1 from 3, so this becomes 2. Okay, and the one that we borrowed, we will be adding to 1/6, which is 6 over 6. So the one that we borrowed is there. We added to 1 over 6, and that's the reason why it became 2 and 7 over 6. So this now becomes 2 and 7 over 6. Okay, and we're subtracting 1 and 5/6. Now it's easier to subtract because now you have 7 minus 5 is 2 over 6, and this is 1 and 1/3 right there. Okay, another way to solve this, okay, I'll show you right now, is that you can just convert both of them into improper fractions. So if you convert both of them into improper fractions, so from here, okay, let me pull that thing and bring it over here. So 3 and 1/6 as an improper fraction is 19 over 6 plus negative 1 and 5/6 as an improper fraction is negative. Okay, I'm gonna plug it in because I'm losing power. Hold on. I have 17%, so we're good. Okay, so this becomes negative 11 over 6. Okay, and since they both have they both have the same denominators, we can do 19 over 6. Okay, minus 11 over 6, make it into subtraction, or this becomes 19 minus 11 all over 6. And we know that 19 minus 11 is 8. So this becomes 8 over 6. Simplify 8 over 6. 4, okay, over 3, or 1 and 1/3. Same banana right there, different boat. Okay, and that's how you subtract mixed numbers. Two ways to go about it. And let's take a look at the last example. 15%, so that'll work. Last example: how do you like to spend time in the great outdoors? The results of a survey on that subject are shown in the graph at the right. What fraction of the people said that they enjoyed driving or swimming? Okay, so in letter A, to answer that question, we have 40 out of 100 said that. Okay, and we need to add 35 over 100 because driving and swimming. And then we add 40 plus 35, keep the denominator the same, end up with 75 over 100, or the simplest form, which is 3/4. Next, letter B, what fraction of the people chose camping or picnicking as favorite activities? So we just simply look at camping, and picnicking, which is 26 and 37 over 100 respectively. And we simply add them. 37 plus 33 will give us, okay, 70, or simplest form is 7/10. Okay, so 7/10. Okay, enjoy camping or picnicking as their favorite activities. And that is the end of our lesson. Thank you for watching.